Welcome, everyone. Welcome, welcome. Welcome. We'll get started as soon as we have a few viewers. Welcome. We'll be getting started in just a few minutes. Thanks for being here. Just getting a few links in the chat. How's the text look on Visual Studio Code? Any feedback? Looks readable. I don't know. Looks a little small. I'm gonna bring it up a little bit. Get a little bigger. Yeah, let's go 18. That's pretty big, but I think it'll work out well. All right, we're gonna get started. Let me get the link of where we're working from. We're picking up where we left off in the Rust book. We're starting with, is it called Chapter 2, Programming a Guessing Game. And so I already created the app using Cargo. I just did Cargo. You can see our previous videos on how to do that, or check out the Rust book. In my case, I call it a guessing GROM instead of a guessing game. So we're gonna this is a good chapter, right? Because we've learned a little bit of basic Rust syntax, and we kind of get to put it in action now. Some of the concepts, like there's concepts in this program that we haven't gone over, and actually we go kind of in depth in the next chapter, the common programming concepts. Excuse me for just a moment. And the so the next chapter we go over it kind of in depth. So I'm gonna try to give, like, as we write this program, I'm going to try to kind of give you a high level understanding of it, kind of a taste of what it means, and then we'll dive in as we hit those sections in the next chapter. So if you're an experienced programmer, some of the stuff may be pretty familiar, and there's probably like some details that may be new if you're new to Rust or systems level programming. And also, like, some of these features, they may be in your programming language of choice. You just don't use them, but they're more prominent in Rust. So we're starting. It's a really simple kind of game where we're gonna ask the user to enter a number to guess, and then we're gonna generate a random number and compare those numbers, and then tell the user if they were above the number, below the number, or if they won. So I'm going to be typing and trying to talk through this. I would encourage you to follow along and type uh, in your editor. Um, so we set up a project. Let's just to show you, it's pretty. Actually, I haven't run this yet, so it'll build and run like we talked about with cargo in the previous video. So it's running. It's building right now. It's going a little slow. I think my computer's struggling with everything going on with the stream and everything. So it's probably going slow. So we're going to build this in a kind of, man, that's going really slow. Rust Analyzer also takes up a good amount of processing power on my computer, I've noticed, which is this plugin for Visual Studio Code that you don't have to use, but it's going to give us a lot of information. It should not be taking this long at all. This is a problem. Let's stop it real quick and see what if I can just build it. Oh man, this is bad. But this is not anything to do with my code. Whatever's going on is probably some kind of system issue because this is all brand new code. I don't know why it's choking up. There we go. Okay, so it's finally built. It's nice. It's kind of ridiculous. Yeah, so I don't know. My system's probably just under tax with the stream and everything going on it, which kind of stinks, but we'll work with it. Hopefully it won't take that long in the future. So I'm just gonna clear this out, right? Just so we can start from new. And the first thing we're gonna do is bring in some other code. And this is we're gonna use the use statement. Those that help text might be too annoying, but we'll live with it for now. I need to calibrate that. So what this means, this first line, is that we're using the standard STD standard library, and from that library we're using the IO module or input output. And so we'll see later on the code where that comes into play. We're gonna declare our main function, which is our entry point function that most Rust applications have. We're going to write some text out to the terminal using the print line macro. We talked about that in the previous videos. We'll dive into macros more later, I'm sure. Yeah, that's kind of annoying. It's a little too much information, I think. I need to find a way to suppress that. I mean, I think we'll like it later, but while I'm just talking through this, it's kind of a pain. So there's another print line. And so this line is interesting. This is where we kind of get into the fun stuff. Okay, let me talk about this for a second. Now, this is going to be one of those concepts that I'm going to try to talk about today. We're going to go into more in depth in really probably the next stream if we finish the guessing game today. So if you're new to programming, if you're not new to programming, you're probably familiar with variables, right? If you're new to programming, this is a pretty new concept, I would imagine. But it's really kind of a fundamental concept of programming. And all it is really is just a way to store and refer to data. When you save data on your computer in your program, that's actually saved to a very specific place that the computer knows where it's saved within its memory, called an address. Those addresses are not very human friendly, right? They're like 0x da 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 whatever, letters and numbers. But with this variable, it allows you to kind of give it a name that in your code you can refer to later. And so in this case, we're naming that piece of data guess. So let's just go through this word for word. So this let indicates to the Rust compiler. Remember, our Rust compiler is coming through our text file here that we're writing, and reading our program line by line. So when it sees this let, that's a keyword that Rust knows. Hey, this is telling me that I am going to save a piece of data to a variable. Okay. Or I guess probably a more appropriate way, if you get lower level about it, it's you're associating a memory address to this identifier that's called guess. So this mut, MUT, is short for mutable. And what that means is that this variable can be changed. Okay. With other languages like Python and JavaScript, if you just declare a variable, it is by default changeable or mutable. In Rust, because it is a systems level programming language, the variables are immutable by default. And with this this line of code here, we're creating a variable that's actually an empty string, and I'll talk about that in a little bit. But I'm saying that right now so you know that this mut or mute, we need that because guess we're going to use that for something here in a little bit, and we need to be able to change it, especially since it's just an empty string. One thing I want to mention in my just a side note in my ID right here is this grayed out text you see is actually, I didn't type that, if you noticed. It's actually being given to me by a plugin that I'm using called the Rust Analyzer, and you can see it says it down here in little letters. When you set up your Visual Studio Code, I'd recommend using Rust Analyzer. There's another one that you can use, but I recommend that one. It also, this right here, this run debug, I can't even highlight it because I didn't write it. It's not text. It's like, you can think of it as like decoration, I guess. It's just, it's actually kind of neat. It'll run my program for me. I don't need to run it right now, but I can just click this and it'll run it. And then like this, anytime you see this grayed out text is text that I haven't typed. Well, this equal sign I typed, right? But where it says string here, what it's saying is that it's a decorator telling me that this variable is a string. Now it's pretty obvious here that this is a string because we're calling it a string right here. But later on in our program, you'll see where that can be helpful. We don't always need it. This program's pretty simple, so it's kind of extraneous. But in the future, you may be, I don't know, either in a file where you're referencing a variable that you don't, is not in this file, or you're in a program that's 50 lines long or something crazy like that, or more, and you don't instead of having to scroll up or right click and go find the definition of the variable, it'll tell you like what type it is here. And these types are important because they indicate what we can do with the data and what kind of data it will accept. So just to recap before we get to the other side of the equal sign, we have this let mute. I'm going to call it mute, short for mutable. Guess. Let means it's a variable. Mute means it's changeable or mutable. Guess is the name of the variable. And then we have the equal sign that the equal sign operator I typed in. Starting there, again, this text here is not typed by me. It's just decoration, informational decoration. And then I've typed on the other side of this equal sign is string : new parentheses. Give me just a moment to take a sip of water. Okay, so this string here, where it says string, so this is actually highlighting here is we're getting some good information that we can read now. So a string is a certain kind of data type. It's a growable string, so that means when we create the string, we can make it a bigger, piece of data. UTF-8 encoded. I'm not going to go down that rabbit hole right now. It's just kind of talks about the way the text is encoded. So different because in the past there's been a lot of compatibility problems with the way text is encoded, but this is pretty standard, so we're not going to worry about that for now. So it says the string type is the most common string type that has ownership over the contents of the string. It has a close relationship with its borrowed counterpart, the primitive str. So that str we'll see later. All that I'll say that you can take from this is that a string is like a piece of text. It's a line of text that can grow. It can be letters, it can be numbers, it can be any number of symbols, that we generate with our keyboard, and I think even emoji now are included in that. Okay, so we're going to see other data types as we go along. We're going to see integers, we're going to see floats, and those are defined using like U8 or things like that. But for now, we're just focusing on the string data type, which is text. With text, we can't do like mathematical operations, right? You can't really like add one string to another because it's all just letters. Like, how do you add an A to a B or something like that, right? And then we have these two colons that kind of bring in this what is called an associated function, um, called new. And so we're calling this function out of this string type. It has an associated function called new, and these parentheses indicate that the function is being called. Okay. And so what this piece of code right here, the string : new, is creating a new instance of a string data type, like we talked about, and it is associating it with the name guess that can be changeable. Okay. If any questions come up, as always, let me know. So you're going to hear associated function. That's something to just be aware of. Not quite the same thing as like a method, which we'll hear about in the future. But associated function is because it is associated with this data type rather than like a an object or something like that. Yeah. Okay. So right now we have, just to recap, we have two lines being printed out to the terminal console, and we have this variable called guess being created. That's a new string type. Okay, or new string data type. I'm gonna go ahead and run. I'm actually going to use this fancy button up here, run button, just so you can see it. I'm going to bring the console up a little bigger so we can have more room. Just to see what happens, right? We're not done. There's nothing really too fancy happening here. Let's just make sure our program is running the way we expect. And so there's actually some warnings here, which I'll talk about. But this is our output. And this is what we want, right? Guess a number, please input your guess. Yeah, we wanted that printed out. We wanted that printed out. Great. This shouldn't do anything because we didn't tell it to do anything, right? It just exists in our computer memory when this program is being run. So this is giving me some warnings about that because Rust is very mindful of memory usage. And so it's saying, hey, you created this program, and you got these lines that came out as text, but then you create this variable and nothing's ever going to happen with it. So just a warning, not an error, but a warning is that you can just remove this variable because you're not using it right now. But it's not going to stop my program from running, right? Because there's no like problem, there's no like issue that's going to cause like problems with this being created. It's just a kind of a waste. All right. Okay, so let's go ahead and continue on. It's going to get more exciting from here. So what I'm doing now, which is kind of hard to see, is bringing in that I/O input-output module we brought in up here. I'm bringing it into scope and referencing the standard in, which, let me just type this out and then we'll talk about it because there's a lot here. In the meantime, feel free to post any questions. If you're watching this on YouTube later, you can always come to the GROM's Discord chat, which there will be a link to that in the, this is what happens when I try to type and talk at the same time. In the YouTube video description. If you're watching this live on Twitch, the GROM's Discord is available. I'm messing up. In the channel description and in the chat. Okay, So one thing just to note, this is actually like this is kind of annoying me, all this gray stuff, because it's kind of making this even harder to read. But I'll walk you through it. So just remember like this gray here, this gray here, this gray here, this gray here. I did not write that. That is decoration like we have up here. Another thing to mention is that this that you see here broken up can all be on one line. But we've broken it up into multiple lines with this at this dot just so it's easier to read, okay? But if you wanted to put that all in one line, you could. It's just if you're following along in the book, you'll notice they break it up. But and in general, you want your code to be readable because you want to be able to read it when you come back and look at it. And when you're collaborating with other people, which if you're become a professional programmer, you will inevitably need people to be able to read your code. You want it to make it easy to read and easy to understand and easy on the eyes. You stare at the stuff all day. You want to make it as easy as possible. Okay. All right. So let's talk through this. This one's gonna be there's a lot going on in here that's new for us. So this again is going to be some information that we are that we're going to touch on to some extent today, and then we'll see more of in the future. So as I was saying when I started and then stopped, this IO is our input module that we have brought in up here. And this associated function is standard in. And so thankfully if I hover over this just right, we can get this description in Visual Studio Code that pops up again, thanks to Rust Analyzer. If you don't have Rust Analyzer installed, you're not going to see this. I'm not sure if any of the other Rust Visual Studio Code plugins have something like this, maybe. So what does it say? And I'll be honest with you, some of like this documentation, if you're new to programming, it's a lot of words that don't always make a lot of sense. So I'm going to do my best to talk through it. I'm going to read through this and then we'll talk through what it means. Okay. Constructs a new handle to the standard input of the current process. Each handle returns as a reference to the shared global buffer whose access is synchronized via mutex. If you need more explicit control over locking, see standard locking method. All right. So I guess what we can do is just call it, I think probably the best way, because there's a lot of information there we don't really need right now. What we can know is that this is a handle. This is a way to like get access for that your computer program is able to access the console line. So when your user puts in text, your computer program is able to see that text that your user enters and get a handle on it. Okay. And then the next line, now that we have that handle, this read line method or function uses that same handle that it's connected to via that dot. See, this is like a chain of functions. This read line is happening on top of this standard input handle. The read line is locking the handle and reads that input. Okay. So I think maybe a way to think about it is and this is an on-the-fly metaphor. It may not be perfect, but I think it'll help you understand it if it's a new concept. The standard in is kind of like if you're a sniper, with your gun or something, your standard in is kind of like putting your scope on it, right? It's getting access to where that information is. Then your read line is pulling the trigger, is actually grabbing the data from that line of text. Okay, and then when it reads that line, it's going to store the data that it reads from the standard input handle. It's going to store that data that it reads into our guest variable that we created up here, right? Get out of the way. So our standard in handle gets read by our read line, and it saves it in our guest string variable. So that's why we created this, and notice why we made it mute, because here it's just an empty string. After this line, it's just empty string. We need to change it from an empty string to be able to take whatever information we read off the standard input. Okay? And then, I don't know how much we're going to talk about what this means today, but this mute, uh, just know it's there for now, right? And don't be scared of it. We'll learn that when we need to. This mute, it's an ampersand, right? On your key, it's a shift 7. On your keyboard, it's shift 7. And then there's this mute, right? And that's just saying that, hey, this guess variable we're grabbing to put something in, we're going to change it. So make sure that it gets passed through our method, because just think that this guess, this empty variable here, it's actually getting borrowed and put into this method. Excuse me for just a moment. And that's a bit of a spoiler alert. This ampersand actually means it's borrowing. It's borrowing that variable. And it's changing it. Okay. I'm just sorry, this is a reference, right? So in Rust you'll see this ampersand called a reference. Okay, and then so we're not done with this line, right? Remember, this is all one line of code. These 3 lines here are one line of code, and they're chained method called expect, and then it has this text in here: failed to read line. What does that mean? Okay. Well, here's something that I'm glad we actually have our information here. Okay. We have this information here, and so if you see where it says result, and it has this like less than sign, use size, comma, error, greater than. So that is actually telling us what this method is going to send us back or return. That's what this function is going to return for us. So in Rust, we have a data type. Like, remember, string is a data type. Another data type we have is called a result. And a result is a much more limited data type than a string. This result, it can only be one of 2 things. It can be a use size, which we're not going to get into today, or it could be an error. And since it's returning that, it's returning a possible error. Whenever Rust sees that there's a possibility that there will be an error, Rust, it requires us to do something about that possibility. And there's different ways of error handling that are important, because with a systems level programming, if something fails, it needs to fail gracefully. It needs to make sure it doesn't cause any corruption or crash the computer. The worst case scenario is that the program needs to crash and just stop. Okay. Excuse me. So in this case, we're excuse me for that. If that was too loud, I don't know if you heard my text message come through. In that case, we have this .expect. And what this is doing is that this is saying that in the case that an error comes through, it's going to give us this message, failed to read line, and it's going to put it out for the error handling to grab. Okay? So that's a lot. And I know that this part is probably fuzzier than anything, right? Like, what result? What is that? That's, this stuff is, will come with time. But just like have the general idea that we're getting a hold of that console line that our user is going to enter text in, and then we're going to read it. We're going to read that data, and we're going to save the data into the guess variable. After this runs, it's going to give us a result of some kind, It's going to be either a usize or an error. And then because that there's an error, we handle the error with this .expect. And again, there's a number of ways to handle errors. This is just the way we're handling it in this program. Okay. Now, just to be clear, all this stuff is being detailed in the book. I suggest that you either, I don't know what order is going to make most sense, right? Watch this video / stream and then read the book, or read the book and then watch the stream. I suspect that watching the video will help first, but I could be wrong. So the book actually does a good job of going into how to handle potential failures with this result type. That I think it's definitely worth reading. It talks about how result types are enums or enumerations, which I believe, there's a whole chapter on enums later on, chapter 6. So we'll get a lot of coverage there, right? And again, I'm pretty sure there's a whole chapter on error handling. Yep, chapter 9 is an error handling chapter. So don't worry if this isn't if this isn't crystal clear yet, okay? All right, so let's go ahead and run our program here. And let's see, I just want to make sure I'm in line with the book here. I'm gonna use cargo run on my terminal down here. And look, it's asking me for a guess now. Okay, it worked. Now, so let's remember what happened, right? We had this whole line ran, and for a moment in time, while the Rust program was running, this 89 was sitting in my computer memory in the memory address that is associated with this guess variable name. Pretty cool, huh? Right? I mean, I don't know. Maybe it's not cool, but that's cool to me, right? That's like the building blocks. From there, like, we're starting to make sense how our data gets saved in our computer and how it runs in programs. And that was stuff that was never, like, it took me a long time to figure out, because I don't know. I don't know if either I didn't pay attention or people didn't explain it to me very well. I'll take responsibility for it, right? Okay, so let's get some more code in here. We're going to add our, yes, so we're going to add our little output here. So what we have so far is our 2 lines prompting the user. This line here allows us to read what the user enters and handle the error and save the guess if it's there. So, well, let's do something with that, right? This is kind of a pointless program so far. I mean, we're learning stuff, so that's not pointless, but let's at least try to put this guess out on the line, so we have proof that our program is doing something, right? All right, so let's run it again. I'm gonna clear this so just so we get a clear terminal. Now I'm gonna type cargo run to run our program. It's gonna compile. I don't know, it's gonna take a long. Oh, okay, didn't take too bad. All right, so guess the number. Please input your guess. Great. Let's put in 72. You guessed 72. Great, it worked. All right, so that's cool, right? We have some validation that our code is doing something. It's not just tricking us, right? Okay, well, now we get some more fun. We get to generate our secret number. And for that, we're going to go into the cargo.toml file. Now, this is a file we took a pretty detailed look at last chapter and last video. So let's go add something to it, okay? So just as a quick recap, the package section up here gives us information about the application that we're writing. Actually, we give that information, right? Yeah, and actually, what's interesting, if you ran cargo new and create this program with your Rust up to date, you may have a different number here. This is 2018. 2021, I think, is now shipping in production. So I haven't updated the Rust version on my computer, so I have this older version, which is fine. We're not doing anything fancy that I need the latest and greatest. But that's just something to be aware of in case you see a 2021 here instead of a 2018. So we're and then so our other section here is our dependencies, and this is actually where a lot of the Rust magic happens, so to speak, because we're gonna with this one line. Just again to be clear, I'm not actually writing Rust. This is Tom's obvious. Oh man, what is it? It's Tom's obvious something language. I called it markup language. I know it's not right. I can't remember. It's not important, but you can look that up if you really want to know. So this is not Rust. This is like it's just a really simple language for us to be able to spec out these this important information, right? And so what I've done here is I have brought in a crate. You go to crates.io and search for Rand. Actually, I think it'll probably crates.io, the website. You'll probably see Rand at one of the most popular crates on crates.io, the crates directory. You'll probably see Rand, and I don't know if because Rand is used so much, which I'm sure it's used a lot, or if it's because it's a part of this beginner program that so many people come through. Either way, I'm listing this, right? So nothing's happened yet other than I have this statement in my program. And so this check mark is just giving me, I'm not sure what this is. This is information, again, from Rust Analyzer. If you don't have it, it's probably because you don't have Rust Analyzer, and that's fine. Don't worry about it. But I didn't type that, right? All I typed was this part. So now that we have that declared, and then I save the file, I'm actually just going to come in here and run cargo build, okay? I haven't, let's remember, let me just click over CC. I haven't added any code here since we last built and ran our program, okay? I only added this line into my cargo.toml file. So I'm going to run cargo build and we'll see what happens. Blocking, waiting for file lock, unpackage, cache. Okay, I think my Rust analyzer is doing something. I don't know why it's saying that. So I'm going to give it some time and I'll talk while that's happening. Hopefully after this cargo check operation down here happens, hopefully it'll finish. Okay, so actually I need that open. So what's happening? What should be happening? And it's not because it's stuck. We'd have more output. When I put this in and I run cargo build, cargo should be going into this file and seeing that I added this new line to the dependencies section. And so using that name, it's going to go to crates.io. Now it's obviously not going to go to the website that you go to, but it's going to access an API that's available from the crates.io servers. And it's going to look for this Rand crate, and it's going to get the specific version that I put in, and it's actually going to download it into my repo here. But I don't know what's going on with my system. I'm really sorry about the problems we've had today. We won't have these problems shortly. Yeah, I'm going to have a fresh environment to work with normally. Let me just step out of my terminal real quick. I'm going to work in my Mac OS terminal. You won't see it. I just want to see if I run it there, if it's still having problems. So I'm still here. Oops, excuse me. You just won't see what I'm doing. So what I'm doing is I'm running this for my terminal to see if this will build here. No, I'm getting the same issue. All right, well, we have fun now. So I'm getting the same issue there. So I don't know quite what's happening, but we're going to find out. It says waiting for file lock on package cache. So give me just a moment here. I'm going to clear my throat. Okay, so it says blocking, waiting for. Let me go back into my terminal here. I'm getting the exact same error when I run on my native Mac terminal, so it's not session related. So let's just run that just so we can get that error up and we can talk about it together. It says blocking, waiting for file lock on package cache. So this is my suspicion. So there's something going on behind the scenes in either Rust or in this repo that is having some kind of it's like it's waiting for either this to update. This file is done to. Yeah, so I feel like I'm just not quite sure what's happened. But it says wait for file lock on package cache. So whatever like monitors the crates that are in this repo, it needs to, I guess it needs to be locked. I'm kind of talking out loud as I try to work through this, or saved so it's like static and things aren't happening while that's in progress. So what I'm going to do is, we're going to do the typical programmer move here. And let me try this one more time. No, we're getting the same thing. Okay, so let me switch my screen so we can Google this together, okay? Just a moment here. All right. Okay, it's live. All right. So there's the Rust book that we're working off together. I'm just going to Google this real quick and see what shows up. Stack Overflow, typically helpful to some extent. Building. So this is interesting. Just get rid of this. Okay, so it says I follow the README instructions for building parity. That's interesting because I think that's like Polkadot or Ethereum library. Yeah, parity. Yeah, Polkadot. Okay, anyway. It says running cargo clean seems to fix the problem. I wish it gave us more information about what's happening. Yeah, so I think something happened when we were, and I'm speculating here. This is getting to the compiler that I'm and compilation process that I'm very familiar with. I think what happened was, is that when my program took a long time to build earlier, I think when I interrupted it, that may have caused some problems. So it's interesting just seeing everyone's response here. This happens when you run two compilations of the same project. Oh, interesting. Okay, that is another possibility. See this right here? PQ. Okay, so there's a number of possible things, and basically it means like there was some kind of collision where things were running together, or things were like kind of overlapping each other on the back end of this process on my computer. So I'm gonna try a few of these things and see which one works. None of these seem too dangerous. This one says they remove this index, which I think that's fine. One, because this program's not like some big investment that I'm worried about losing. I can recreate it easily. And two, this I think that whatever is in here, if it's missing, my cargo will automatically generate it. Don't quote me on that. I'm just kind of speculating. But this one seems like the highest the easiest one. So we're going to try that. Let me just switch over back to our IDE, and we can try it together. Okay, so it looks like the IDE is live. All right, so I'm just going to try cargo clean. Maybe that'll fix it for us. What concerns me is that this is still going right here. I think this may continue to be a problem. This cargo check and Rust analyzer. Because basically, yeah, I think this is actually the problem. Because cargo is running 2 times, basically. My IDE is running it, and then I'm trying to run it here on the terminal. It's running 2 instances of cargo on the same repo. Let's just see what happens. Okay, so cargo clean seemed to work. So let's just try cargo build, see what happens. Nope, we still got the same issue. Okay, so this is my suspicion. My suspicion is it is this. I don't know why this is still running. I need to see if I can kill it somehow. That's not important. Okay, so I'm going to try that RM RF, which, just to be clear, be careful with this command, because this is RM stands for remove. So if you're whatever you put after the RM, it'll be removed, right? There's no like, hey, bring it back. It's gone, as far as I know. I don't think there's a way to bring it back. Are you sure, Adam? Yeah, that even sounds. I don't know. That kind of scares me. I mean, like, I don't think it would do any damage, but I'm worried that it would cause, like, whenever I try to build something again, it'll take forever. So I'm gonna say no just for now, and I'm actually gonna. Yeah, actually, this was okay. Yeah. Did I post the link to this? Let me post a link to this. Stack Overflow. But just to, you can easily search for this by taking that error we saw, blocking, waiting for file lock and package cache. You plug that in Google, this will be the first response or first result. Yeah, so there's this person that says you usually get this error when you run cargo build command twice at the same time. You're using an IDE check if a plugin is running a cargo command in the background. This was the case for me with VS Code. So this is precisely what's happening. This cargo check is still running by the IDE is running it, and I'm trying to run cargo at the same time. So I wonder what's the best way to kill this. I mean, obviously I could probably restart Visual Studio Code, and that would do it. But I'm hoping there's something where I can just like close that and get the yeah. That's what I'm hoping there's a way I can just stop these. No, those just show. Oh well, it just went away. Something happened. Okay, I don't know. Maybe not. I felt like something happened. Maybe not. Let's see what happened. I'm gonna try to cargo build again. There we go. All right. I don't know what happened, but we fixed it. Okay. It may have been just waiting. I think there was just it was kind of stuck in that process. So again, I think my streaming and everything is just taking its toll on my computer. So yeah. Hopefully these next week I'm gonna have a new environment and this shouldn't be a problem. But it happened, right? So to go back to where we're at, all we've done since the last time we build was add this file or add this line, and we told Cargo to build. And so without even touching our actual Rust program, Cargo read this TOML file and went and downloaded and compiled these dependencies. Now all we asked for was rand, right? That's all we have up here, and actually gave us 0.4 just because it knows that is compatible and newer. But we didn't ask for all this stuff, right? Well, Rand actually has its own dependencies. So if you were to go look at the repo for Rand for this version, you would see I would bet, I haven't confirmed this, but because there may be other ways to manage dependencies, but at some point there's essentially a cargo .toml file for Rand that lists these other dependencies and pulls those in. So that's why we just asked Rand, but we got all this stuff. Now you shouldn't ever really need to do this. Where does it keep this? I need to refresh this somehow. Anyway, well, we're not gonna worry about it right now. Yeah, here we go. So if you actually dig into here, you can start to see some of the stuff that we you never need to do this, okay? But just so we know a little bit, and just to hit the button that I always like to hit, it's all just text files, right? When Cargo went and got all this information for us, this is where it put it. It's in this folder that you probably won't ever have to go into, but it's here, right? If you go in here and start changing stuff, you can't even. It's not editable really. If you start changing this, it's gonna give you problems. So don't touch it, right? But you can go in and look at it. Just don't save anything. But this is where everything's being stored, right? There's no magic here. Let me close this. There's Cargo is not doing anything magic with these files. They're not hidden somewhere in your computer where you can't get to. It's all here, okay? That's all I want to highlight. That's the only reason I showed that. But you don't need to go in there, right? You don't need to go in the debug. You don't really need to go in the target folder right now because we're using Cargo. Cargo, if you remember, our application is actually in here as well. That's our application. We can't watch it. We can't read it because it's it's a binary. It's not really human readable. I mean, we could we can physically look at it, but it wouldn't make any sense to us. But instead of going in that folder, right, we just do cargo run, which, by the way, now that we've built, right, remember we just build the program. We didn't run the program because we use that cargo build. And we know that when we do cargo run, it's going to build and run. The build process should be really fast because we just built and didn't change anything. All right. So it's the same, right? This is the same program. Okay. I think we're going to stop there, right? We made some good progress on our guessing GROM game, and we're hitting about an hour. So I think this is a good place to stop. Let's just take a look. Coming up, we're going to have what do we have coming up next? Oh yeah, we're going to implement that random. So that crate we implemented, or excuse me, not implemented, the crate we added to our program, remember it's Cargo hid it down in this target folder down in depths and everything. We're going to use some of that code in our application. We're going to, what is it? Yeah, ring, I think is what we use. Oops, excuse me. And then we're going to use this library. Remember, this is the library and this module to generate a random number that we can that our user can guess against. So quick question, or that may occur to you if you were paying attention, is why didn't I have to bring this in Cargo, right? I don't have anything that says std equals some number, right? No, I don't have that. Well, std is the rough standard library. It's telling us right here, right? It's a foundation of portable Rust software, a set of minimal and battle-tested shared abstractions for the broader Rust ecosystem. So what that means is that the Rust installation on my computer already has that code sitting in it for me to access. It's a very, that library is highly curated. They only bring in stuff that's absolutely common across any kind of Rust programming. because they want to keep that small so that the Rust compilation process is, is as fast as it can be. It's still like can still be long, but that's why we didn't have to actually put this std in our cargo.toml. We just put ran. Ran's coming from somewhere else, right? We're getting it from the crates directory via download. Std, the standard library, is sitting in our Rust installation for us to reference it whenever we want. Okay. All right. Any questions before we wrap up? All right. Thanks for being here. Just a quick run through of what we started at the beginnings of our guessing GROM game, or our guessing game that you can find in the Rust book online. I certainly recommend, if you have the time, to move ahead of me and start building out this program. And then tomorrow, not tomorrow, Wednesday, but when this next video comes out, we're gonna finish the program, and I'm gonna make some recommendations around what you can do next to this program, because at the end of this chapter, the program's pretty simple, but there's some pretty cool ways that I think you can add on to it and make it better. All right, thanks for being here. Thanks for watching. If you're on YouTube, thanks for watching this. Consider minting a GROM NFT at paddleout.groms.club. If not, definitely completely free. Come join the GROMs Discord and let us know how your Rust journey is going. If you have questions, we just want to build a place where people can help each other learn Rust and maybe eventually become Salon developers as well, if that's what you want to do. But there's so many cool things you can do with Rust. It's worth learning regardless. All right. Y'all have a good one.